So here we've got three matrices, right? So basically what I'm going to ask is just, we're not going to necessarily multiply all of these things together and stuff, but I want to know which of the following products are valid. Meaning, basically the question is going to be, I'm going to write down a bunch of matrix products, like, for example, A times B. Okay, and the question is this allowed? Are you allowed to multiply A times B? So let's start with a few here. Okay. Yeah. Not anything like this, because this is we're now on, what is it, 2.3 or something? So the test goes up to 2.2, but test number 3 during the exam period will have stuff. Well, it could, in theory, have stuff like this. I don't know if it will or not, but I haven't made the test. Yeah. So the test is, I mean, technically the test is 6.4 up to 2.2. However, if you go through practice questions in 6.4, for example, or even chapter 7 and stuff, you'll realize, like, in order to do some of those questions, you need to know how to do the counting stuff. So in some sense, it's not cumulative, but in another sense, to do stuff in for example, 6.4 or 7.2 or 7.3, you need to know what, like, n choose k is and stuff. So it does build on previous stuff, right? And this is, by the way, the test is going to be on Wednesday in this room. Yeah. Sorry? No what? Oh, no God. Okay. If you all get them all right, then that'll be fine. Oh, so there are some already. I didn't make an announcement about it, but there are some practice tests on Brightspace. So if you go to tests and then so it's on Brightspace. You go to tests and then like old tests or something. There should be, in that list, I think there should be some for test 2 as well. One thing to note is the cutoff for test 2 is not the same in every year. So you might see some questions that we did on test 1, or you might see some questions that we're going to do on test 3. It's not perfect, but I think the old tests are probably the best thing for studying, I would say. Any other questions about the test or anything like that? Yeah. Okay, so which of these products are valid? So my question is, am I allowed to multiply A times B in this case for these two matrices? So maybe thumbs up, thumbs down. Who thinks we can and who thinks we can't? Pretty kind of 50-50-ish. So A is 4 by 2, right? 4 rows, 2 columns. B is 2 by 3. As it turns out, we can multiply these. So the answer is yes. Because the number of columns here equals the number of rows here. So this is okay. So the fact that this 4 is not equal to this 3, it doesn't matter. What matters is, they're both, this has a 2 in the second spot, and that has a 2 in the first spot. So yeah, this is possible, and if I take the matrix A times B, it is, actually, what's the size of A times B in this case? Yeah, 4 by 3. Right, to get the size, it's kind of like these 2's in some sense cancel, you can think of it that way, and it's 4 by 3. Am I allowed to do B times A? Thumbs up, thumbs down. Okay, yeah, indeed. So this is not valid because B is 2 by 3. This is 4 by 2. If I do 2 by 3 and a 4 by 2, this does not match this. So you can't multiply 2 by 3 by a 4 by 2. Yeah. Yeah, that's the thing. For numbers, A times B is the same as B times A for numbers, right? But the multiplication for matrices is a different story. Yeah, yeah. You can't just switch them. Yeah, yeah. But that's part of like what we're trying to see here is that it's pretty tempting when you're dealing with multiplication to just switch the order because you're used to doing that with numbers. But with matrices, you can't. So generally speaking, AB is not the same as BA. We'll see another example of this later, but in fact, and in this case, AB is definitely not the same as BA because BA doesn't even exist, and AB does. So yeah, they're definitely not the same. Am I allowed to do A times C? Thumbs up, thumbs down. Yeah, so I'm not allowed to do A times C because this is 3 by 2. This 2 is not the same as that 3, so it's not valid. Okay. Any questions about that? Okay, so last time we talked a little bit about how to, like I gave some examples of how to multiply matrices, but I feel like we need more examples. So let's, well also I think we need to be clear on systematically, if you had 2 big matrices, how would you multiply them? So let's look at A times B for this example. Okay. So this is generally how you compute it. So the entry in the ith row and jth column of A times B is basically the number you get by multiplying the ith row of A by the jth column of B. I should probably clarify again, what do I mean by multiplying a row by a column? Because it's a bit of a strange operation. let's, so again, A and B are still these matrices. So let's say A, B, I'm just going to write the entries as like, I don't know, x11, x12, x13. You wouldn't necessarily need to do this in a, you don't necessarily need to write all of this when you do this, but this is just for explaining how you get each entry. So x42, x43. Okay. So it's supposed to be 4 by 3, right? Okay. And for example, if I wanted to get x32, what I do is I take the third row of A. So the 3 here means I take the third row of A, which is 3, 5. Okay, so that's what this 3 indicates. I should be taking the third row of A. I should be taking the second column of B, 1, 0. Okay. And then we kind of, we need to now remember this rule for how to multiply a row matrix and a column matrix. So when you have a row matrix of length n or whatever, a column matrix of length n, what you do is you take the first element times the first, so 3 times 1, plus the second element times the second element, so 5 times 0. So it'd just be 3. So that tells me that this entry of my matrix should be equal to 3. Okay, like I said, you don't necessarily, well, okay, if you are, you're probably not going to be given a question this big on a test or something to have to compute 12 different numbers. But if you were, I guess you would have to write some steps. But okay, I don't necessarily always have to write these column and row matrices. So I could say x41, or yeah, let's say x41. I take the fourth row of A times the first row of B. So that's 0 times 0, which I get from this times this. And then I do this times that. So 1 times -2. So that's -2. Okay. And then you just literally just keep filling in these values. So yeah, if I want the thing on the third row, first column, I would take this row times this row, multiply, add them up, and that'll give you the value. Okay. Any questions about the procedure here? Okay. So to be clear, like here you would do 12 different calculations, right, to get these 12 different entries. Okay. So maybe let's give you a bit of practice doing this on your own. So for those two matrices B and C, I'd like you to maybe take a minute and try to compute B times C. And feel free to chat, work together, ask me questions, and this one's not a trick question. This product does exist. Right? It would, yeah. And it's most likely going to give you a different answer to do C times B, I think. I'm not sure, though. Yeah, if you're finishing this really quick, then you want more practice, then multiply C times B, right? But let's focus on B times C first. Does anyone have the top left entry yet? Yeah? Yep. Right, and I agree with that. You take your 0 times 3, that's 0. 1 times 8 is 8. 2 times 1 is 2. Add them up, you get 10. Yeah. What about like, I don't know, top right entry? -2, yeah. Does everyone get -6 and -8 as the rest of it? Maybe? Okay. Did anyone do C times B? Because I have no idea what it is. I didn't do that one in my notes, but oh, it's definitely going to be different than B times C because it's going to be bigger, right? C times B is going to be 3 by 3, but B times C was only 2 by 2. But yeah, I guess this one's like 9 different calculations. Yeah. Maybe I won't kind of bore you with doing them all, but yeah, but let's say like the top corner. So that'd be 3 and 4, that row versus this column. 3 times 0, 4 times -2, -8, right? And then so on. So it's going to be a 3 by 3 matrix and 9 different values, right? And then you can see again, BC is not the same as CB because, in fact, this one's 2 by 2 and that one's 3 by 3. They're different sizes. Yeah. Yeah, so the 10 comes from, you take the first row of this, which is 0, 1, and 2. You take the 0 times the 3. So this is generally how this always works. You take, the first thing here times the first thing on this column. The second thing on this row times the second thing on that column, which we add to the previous thing, and then we add the third thing times the third thing here. So that's how you get the 10. Any other questions about this one? Okay. So let me tell you some properties of matrix multiplication. So, or maybe laws, I guess sometimes they're called. So laws of matrix multiplication. Okay, so for any matrices A, B, and C, so the first sort of law is that if I take A times B times C, assuming, like here we're assuming that this product makes sense, right? If the product doesn't make sense, we wouldn't multiply it. So assuming this makes sense, then A times B times C is the same as doing A times B times C. So if you're, basically the idea is if you're multiplying like 3 different matrices, the order you do it doesn't matter. Like in the sense that, okay, the order of the things here matters. You can't move them around. But what I mean is if I do AB first and then I multiply by C, that's the same as doing BC first and then multiplying by A on this side, like this. Second rule, oh, this is called associativity. So matrix multiplication is associative, meaning basically I can, well, you can just bracket it in different ways. Second thing is if I take A times B plus C, then just like with numbers, I can bring this product inside. So it's the same as A times B plus A times C. This is distributivity. Okay. But note, so this is something we've now mentioned a few times. If I take A times B, it's not the same as B times A. Okay, so matrix multiplication is not commutative. Commutative, like a multiplication is commutative if you can do it both, if like A times B equals B times A, just like with numbers, right? A times B equals B times A. And here we're saying matrix multiplication is not commutative. You can't just switch the order. Okay. We've already seen a few examples of this, but let me give you one more. So if I take this matrix 1, 1, 0, 0, then I multiply by 0, 0, 1, 2, you get 1, 2, 0, 0. It turns out if you do the multiplication, you'll see that. But if I do it the other way around, 0, 0, 1, 2, and I multiply by 1, 1, 0, 0, so I've just switched the order, you end up with something totally different, which is 0, 0, 1, 1. So if this is like my A and my B, then this is A times B. If this is, but this would be B times A. And they're not, they're totally different matrices. Okay, any questions about that? Okay, let's do a quick kind of a question using these laws of matrix multiplication. This is kind of a funny little question. So suppose A and B are matrices such that A is 3 by 5 and the product A times B exists. Okay. And then the question is, what is the size of B? Kind of a weird question, but okay, so yeah. Oh, was there? Oh no, I thought it was a question. Sorry. Okay, okay. Yeah, so it's kind of a funny question, but basically what we're going to use here are two things. Like one thing is this rule about matrix multiplication and the size of the matrix. So there's this rule we have that number of columns of the first matrix must equal the number of rows of the second matrix. And the second thing is we're going to use one of these laws of matrix multiplication, the associativity law. So here's the thing. If A times B exists, well, then in particular, B times B exists, right? Well, because I couldn't take A times B if B times B didn't make sense. But if B times B exists, what does that tell me about the rows and columns of B? Yeah. Have to be the same, yeah. Because, this, yeah, the number of columns in the first matrix must equal the number of rows in the second. But both of these are the same matrix, so really this is saying, so therefore, number of rows or number of columns of B equals number of rows of B. But then note that this matrix here, if I do A times B in brackets, that's the same as if I bracket the other way. Right? So that's what the associativity says. I can move the brackets around. So therefore, oh, these little dots mean therefore. So A times B must exist. Okay? which tells me that if AB exists, then the number of columns of A must equal the number of rows of B. Okay, but here's the thing. We know that the number of columns of A is 5, right? A is 3 by 5. So this is just 5. Okay, so from this we get 5 is equal to the number of columns of A, which is equal to the number of rows of B. But the number of columns of B is equal to the number of rows of B as well. So B is 5 by 5. Right, because the number of rows of B is 5 from this equation. Then the number of columns of B is the same as the number of rows of B, so they're all 5, right? Oh, so the number of columns of A equals number of rows of B. Yeah, sorry, that is a bit messy. Yeah, so for AB to exist, the number of columns of A must equal the number of rows of B. Is that the same thing you get, 5? 5 by 5? Yeah. This is just a very formal way. You might have been able to guess this, but this is a formal way of proving it, that it's 5 by 5 using this law of associativity. Okay. So next I want to introduce something called the identity matrix. So when you're dealing with numbers, and you're dealing with multiplication, there's a special number such that if I multiply by that number, it doesn't change the answer, which is 1, right? In